A silent mountain of stone holds a secret written in geometry. The Great Pyramid of Giza is not just an ancient tomb, it is a monumental cipher, a frozen symphony of numbers etched into limestone and granite for over 4,000 years. This video will decode the hidden mathematical language woven into its very architecture. By the end, you will see this ancient wonder not as a simple resting place, but as a sophisticated repository of knowledge that may rewrite our understanding of history itself. How did its builders encode the mathematical constant pi without modern tools? What celestial messages are locked in its alignment? We are going to explore the compelling evidence for advanced knowledge of pi, phi, and precise astronomy embedded in its design. This journey moves beyond conventional narratives to examine a legacy of intellect that challenges everything we assume about the past. What does it mean when a civilization leaves its greatest secrets not in books, but in stone? Standing at its base, the sheer physical reality of the Great Pyramid is overwhelming. The desert sun beats down on a structure so vast it seems to swallow the horizon. You are not looking at a building, you are confronting a geological feature carved by human hands. The first and most immediate mystery is not what it means, but how it was even possible. This is a project from the dawn of civilization, crafted with tools of copper and stone, yet it achieves a level of precision that would challenge modern engineers. The numbers themselves are the first layer of the code. The original base length of each side was almost exactly 230 meters. Its original height was nearly 147 meters. More astonishing than these colossal dimensions is their relationship and their accuracy. The pyramid's four sides are aligned to the four cardinal points of the compass, with a deviation of less than 1/15 of a single degree. To put that in perspective, the error is so minute it is smaller than the width of your thumb held at arm's length against the entire sky. The base forms a near-perfect square, with the difference between the longest and shortest sides being less than the length of a standard school ruler. As the engineer John Romer has noted, this is not the kind of accuracy you achieve by guesswork or by sighting along a stick. This is the signature of a planned mathematical operation. So we are faced with a pivotal question from the very start. Were the master builders of Giza simply incredible artisans, or were they, first and foremost, master surveyors and astronomers? The foundation of the mystery is laid not in the grand theory, but in these cold, hard, impossibly precise facts. The smallest deviations here are not mistakes. They are perhaps the most important clues of all, suggesting every measurement was a deliberate choice, a piece of a larger puzzle waiting to be solved. That initial precision is just the surface. The first true mathematical marvel emerges when you step back and see the pyramid not as a static form, but as a dynamic shape in motion. Take the total distance around its square base. Now imagine that perimeter not as a boundary, but as the unrolled circumference of a perfect circle. What would the radius of that circle be? Astonishingly, it is the pyramid's own height. This is the famous pi proportion. If you take the perimeter of the base and divide it by twice the height, you get a number. That number is not roughly 3 or approximately 3.1. The calculations using the pyramid's original, intended dimensions yield 3.1416. That is pi accurate to 4 decimal places. For a structure built over 4,000 years ago, this is not a minor curiosity. It is a shout from the past. The early pyramid researcher John Taylor was among the first in the modern era to highlight this relationship in the 19th century. He saw it as evidence of a divine plan, but the mathematics stands regardless of interpretation. The builders encoded the fundamental constant of the circle into the angles and lines of a square monument. Think about what that implies. To achieve this, they needed more than just brilliant stonemasons. They needed a theoretical understanding of geometry that connected linear measurement to circular theory. This knowledge of pi, so precise and so deliberately embedded, predates the formal work of the Greek mathematician Archimedes by more than 2 millennia. It suggests a school of thought, a tradition of mathematical inquiry that was already mature when the first blocks were set in place. So we must ask, was this a happy accident of simple ratios, or is it the cornerstone of a hidden code? The presence of pi invites us to look deeper, to see if other universal constants are waiting quietly in the stone. But the mathematical signature within the pyramid does not stop with pi. There is another number, one that whispers through the natural world, that may also be etched into this ancient geometry. This is the golden ratio, often symbolized by the Greek letter phi. Its value is approximately 1.618. You find it in the spiraling arms of galaxies, in the arrangement of seeds in a sunflower, and in the elegant curve of a nautilus shell. It is a proportion that many cultures have associated with a sense of inherent beauty and harmony. The compelling question is, did the builders of Giza know of it, and did they choose to embed it in their greatest work? The argument centers on a specific relationship within the pyramid's shape. If you take the length of the apothem, that is the diagonal line running from the very center of the base straight up the face to the apex, and divide it by half the length of the base, the resulting number is strikingly close to phi. This is not a vague approximation. Using the pyramid's most accurate measurements, the calculation yields a value hovering around 1.619, a near-perfect match. Scholars like Mario Livio, who has written extensively on the subject, note that phi appears with such frequency in art, architecture, and nature that its discovery by an advanced ancient civilization is entirely plausible. The aesthetic appeal of this ratio, its sense of perfect balance, would have held profound symbolic meaning for a culture deeply connected to cosmic order. Yet here we encounter a fascinating debate. Many mainstream Egyptologists propose a more practical origin for the pyramid's slope. They point to the ancient Egyptian sekht, a unit of measure for the incline of a pyramid's face. The Great Pyramid sekht is 5.5 palms per cubit, which produces a slope of 51.8 degrees. This is a clean, workable number for architects using simple measuring rods and ropes. From this purely functional perspective, the appearance of phi could be a happy mathematical coincidence, a secondary result of choosing that particular stable angle. So which is it? A deliberate encoding of a sacred ratio, or a practical building decision that accidentally mirrors a universal constant? The truth may hold both ideas. Human creativity rarely operates in single lanes. A master architect could very well have chosen a sekht that was both eminently buildable and secretly satisfying because it resonated with a deeper, observed harmony in the world. The slope had to work, yes, but perhaps it also had to mean something. The presence of phi, whether by profound intent or by astonishing serendipity, adds another layer of sophistication to the pyramid's design. It suggests that its creators were not just engineers, but also philosophers of form, individuals who saw mathematics as a bridge between the earthly and the divine. This leads us to an even grander scale of intention. If the pyramid's form holds the mathematics of circles and harmonic ratios, where else did its builders direct their gaze? Perhaps their ultimate blueprint was not drawn on papyrus, but mapped across the night sky itself. The mathematics of shape and proportion point to a mind that saw harmony in numbers. But the builders of Giza were not just looking at the ground or their diagrams. Their ultimate reference point was the vault of heaven itself. This brings us to one of the pyramid's most silent and profound feats of engineering, its near-perfect alignment to the cardinal directions. The north-south axis of the Great Pyramid is oriented to true north with an error of just 3/60ths of a single degree. To grasp how extraordinary this is, consider the tools they did not have. They had no magnetic compass, as the magnetic North Pole wanders and would have been useless for this kind of precision. They had no satellite telemetry, no laser theodolites. They had the night sky, simple sighting rods, and an immense patient intellect. So how was it done? The leading theory, supported by researchers like archaeoastronomer Giulio Magli, involves the careful observation of a circumpolar star. Around the year 2500 BCE, the star we call Thuban in the constellation of Draco was the pole star. It did not sit exactly at the celestial North Pole, but it circled very close to it, tracing a tiny path in the night. An ancient astronomer could have marked the points on the horizon where Thuban rose and set over the course of a year, bisected the angle between those 2 points, and thereby found a true and fixed north-south line. This method requires not just one night of observation, but a systematic, year-long recording of the star's motion. It implies a tradition of celestial timekeeping, a deep understanding that the Earth's axis has a fixed point in the spinning cosmos. The result of this painstaking work is an alignment so precise that for centuries, the Great Pyramid was the most accurately oriented structure on the planet, more so than the Royal Observatory at Greenwich built in the 17th century. This was not merely a technical display. In the Egyptian worldview, the North, and specifically the region of the circumpolar stars that never set, was intimately connected with eternity. These were the undying, imperishable stars. For a pharaoh whose soul was destined to join the cosmic order, having his monumental resting place fixed eternally to that undying realm was the ultimate symbolic act. The pyramid thus becomes more than a tomb. It is a permanent instrument, a colossal stone compass needle frozen in time, pointing the way for a king's journey. It binds the earthly to the celestial in the most literal way possible. The precision of its orientation whispers of a civilization that did not just watch the stars, but conversed with them, using their eternal cycles to anchor their greatest works to the fabric of the universe. This celestial code forces us to ask, if they could achieve this, what other cosmic truths might they have woven into the very dimensions of the stones? The celestial alignment binds the pyramid to the cosmos, but what of its place on the Earth itself? This leads to a geographic claim of breathtaking ambition. If you were to take a map of all the world's continents and draw a line along the longest stretch of land running north to south, and another along the longest east to west, where would they cross? According to a fascinating theory that has circulated for over a century, that precise intersection falls directly upon the Giza Plateau. This idea proposes the Great Pyramid was built at the geographic center of the world's landmass. The calculations behind this are intriguing. The longest land meridian, running from the northern tip of Siberia down through Africa to the southern Cape, does indeed pass through Giza. Similarly, the longest land parallel, stretching across Eurasia and Africa, is also said to intersect there. Proponents of this view, like the early 20th century researcher Charles Piazzi Smythe, saw this not as chance, but as evidence of a lost, global civilization with knowledge of the Earth's geography that we only rediscovered in the modern age. They argue the builders intentionally chose this central point, this navel of the world, to anchor their monument. The symbolic power is immense. It transforms the pyramid from a national tomb into a planetary landmark, a stone pin holding the map of creation together. For a culture that believed their kingdom was the center of cosmic order, placing their greatest achievement at the calculated center of the inhabited world would be the ultimate statement of divine kingship and earthly dominion. Yet, mainstream geology and geography offer a more measured perspective. They point out that the exact definition of the longest land parallel can shift depending on how coastlines and islands are measured. The calculations are sensitive to minor changes, and other locations could potentially vie for the title of center. Skeptics suggest the alignment, while remarkable, could be a compelling coincidence of geography, not a demonstrable feat of ancient cartography. This debate, however, misses the deeper point. Whether by profound design or by a confluence of natural landforms, the result is the same. The Great Pyramid occupies a location that feels central. It resonates with an ancient concept known as sacred geography, the idea that certain places on Earth hold special power or meaning because of their relationship to the whole. The builders may not have had a satellite's view of the planet, but they possessed a sophisticated understanding of their world through trade, exploration, and myth. Choosing a site that lay at the crossroads of major ancient routes, between the fertile Nile Valley and the vast desert, between Upper and Lower Egypt, already made it a cultural and political center. The notion that they extended this concept to a cosmic scale, envisioning their land as the heart of all lands, is entirely within their worldview, so we are left with a choice between two interpretations. One is a literal, mathematical center requiring impossible ancient knowledge. The other is a symbolic, ritual center, chosen because it felt right, because it balanced the world in their spiritual cartography. Both interpretations lead to the same awe-inspiring conclusion. The builders of Giza did not just build a structure, they built a center. They planted a flag of stone at a point they believed held the world in balance, making their king's legacy and their god's authority eternal and unmovable. This idea of a central anchor point invites the next, and perhaps most controversial, layer of the code. If the pyramid was meant to be a center, did its builders also design it as a scale model of the planet itself? The idea of the pyramid as a world center leads to an even more audacious proposition. What if its measurements were not just symbolic, but a literal, scaled-down representation of our planet? This brings us to the fundamental tool behind its construction, the royal cubit. This was not a random length of wood. It was the sacred standard, the master key to the entire design. But where did this key come from? According to a compelling theory, the royal cubit was not invented. It was discovered, derived directly from the dimensions of the Earth itself. Imagine taking the polar circumference of our planet, that imaginary line running around the globe over the poles. Some researchers propose that 1/40 millionth of this distance equals a length strikingly close to the modern meter. More intriguingly, they suggest that 25 millionths of the polar radius equals the length of the royal cubit, approximately 52.36 centimeters. If this is true, it means the builders possessed a unit of measure born from the planet's own proportions. The implications are staggering. It transforms the pyramid from a large building into a precise model. Proponents of this view, like the metrology researcher John Mitchell, argued that the pyramid's original height, when multiplied by 43,200, a significant number in ancient cosmology, yields a figure remarkably close to the Earth's polar radius. Similarly, the perimeter of the base, multiplied by the same factor, approximates the Earth's equatorial circumference. The numbers align with a precision that defies easy dismissal as coincidence. This suggests the pyramid was conceived as a geodetic monument, a permanent record of planetary knowledge carved in stone for an age that might forget. It raises a profound and unsettling question. Did an ancient civilization possess the ability to accurately measure the size of the Earth, thousands of years before the Greek philosopher Eratosthenes is credited with the first calculation? The mainstream historical record says no, that such a feat required a level of global travel and mathematical sophistication that simply did not exist in the 3rd millennium BCE. Skeptics argue that the correlations, while fascinating, rely on selecting specific modern measurements and conversion factors that the ancients would not have used. They point out that the Egyptian cubit rods we have found vary slightly in length, and there is no surviving text that explicitly links the unit to the Earth's dimensions. Yet, the mathematical resonance persists, whispering of a possibility that challenges our timeline of scientific discovery. Whether by intentional design or by a convergence of sacred geometry and natural constants, the royal cubit stands as a monument within a monument. It represents a bridge between the human scale and the cosmic scale. A builder holding that rod was not just measuring stone. He was, according to this theory, replicating the very proportions of the world. This transforms every block laid into a statement of unity, a declaration that the king's domain and the earth itself were governed by the same immutable laws. If the cubit truly holds this secret, then the Great Pyramid is far more than a tomb. It is a library in stone, its shelves not holding scrolls but dimensions, its language not hieroglyphs but the silent, eternal language of mathematics and measure. This realization forces us to confront the ultimate purpose behind such an encoded legacy. What kind of knowledge were they trying to preserve, and from whom were they preserving it? Look up the face of the pyramid, and you are confronting a choice. The slope is not a gentle ramp but a steep, unwavering ascent of 51.5 degrees. This angle was not the only option. It was a specific, deliberate selection from a palette of possibilities, and the reason behind it may be the most profound key to the pyramid's hidden code. To understand it, we must first step into the mind of an ancient Egyptian architect. They did not think in modern degrees. Their unit for slope was the seect, a measure of horizontal run for a fixed vertical rise. For the Great Pyramid, the seect was 5 palms and 2 fingers per cubit. It is a beautifully practical system. A foreman could simply hold up a rod marked with these increments against a taut cord to check the angle of every single course of stone as it rose. This practical explanation is elegant and sufficient for many historians. It gave the pyramid a stable, buildable form. But with a structure of this ambition, we must ask, was the choice of seect merely about stability, or did the resulting angle carry a deeper, hidden resonance? The moment you convert that practical seect into our modern geometry, the numbers begin to sing. That 51.8-degree angle is mathematically rich. It is the angle whose tangent is 4 divided by pi. It is the angle whose sine is very nearly the reciprocal of the Golden Ratio Phi. These are not vague associations. They are precise, interlocking mathematical relationships that emerge directly from the chosen slope. If you calculate the area of each triangular face and compare it to the area of a square built on the pyramid's height, the ratio is once again phi. This is where the line between practical engineering and sacred geometry beautifully blurs. An architect could have chosen the seect because it was a clean, workable number for his teams. Yet, in doing so, he also, whether he fully understood the mathematics or not, locked into the form a cascade of the universe's most harmonious proportions. The architectural historian Mark Lehner, who has spent decades at Giza, acknowledges this duality. The builders were supremely practical, but they operated within a worldview where numbers held power, where the correct proportions were believed to maintain cosmic order or math. So we arrive at a compelling synthesis. The slope is a masterpiece of intentional duality. On one level, it is a triumph of applied mathematics, an angle chosen for its structural integrity and ease of construction with simple tools. On another, deeper level, it is a philosophical statement. By selecting this specific seect, the architects created a shape that inherently generates the constants pi and phi from its own geometry. The pyramid becomes a self-referential mathematical object. Its outer form whispers the same numbers that govern circles and growth spirals in nature. This was likely not an accident, nor was it necessarily the result of advanced calculus. It could have been the product of an empirical, observational genius, a culture that discovered through trial, pattern, and a deep reverence for harmony that certain shapes simply felt right, resonated with the order they observed in the heavens and the world around them. The slope, therefore, is the perfect fusion of hand and mind, of rope and philosophy. It allowed thousands of workers to build accurately while ensuring the final, majestic form embodied the silent, eternal laws of the universe. This leads us inward, for if the exterior angles hold such meaning, what secrets might be waiting in the chambers and passageways hidden deep within the mountain of stone? The exterior geometry whispers of circles and harmony, but the true weight of the pyramid's message lies in its staggering physical reality. To comprehend its scale is to confront numbers that defy ordinary understanding. The structure is composed of approximately 2.3 million individual blocks of limestone and granite. The average weight of each block is around 2.5 tons, equivalent to a large male African elephant. The largest granite blocks in the King's Chamber weigh in at a crushing 70 tons each. The total volume of solid stone exceeds 2.5 million cubic meters. These are not just statistics, they are a testament to a logistical and organizational miracle that spanned decades. Yet, for those searching for a hidden code, these colossal numbers are not the end of the story. They are the beginning of another layer of mathematical intrigue. Some researchers have looked beyond the linear proportions and asked a profound question. Could the pyramid's total volume itself encode a deeper constant? A fascinating theory suggests a relationship between the pyramid's volume and the volume of a sphere. If you take the pyramid's height and use it as the radius of a sphere, the volume of that sphere relates to the pyramid's own volume through manipulations involving pi. The calculations are complex, but the result is a numerical resonance that again points to a sophisticated understanding of three-dimensional geometry. Engineers who study the project, like those from the French Institute in Cairo, often separate the speculative mathematics from the physical achievement. They note that moving 70-ton stones up ramps and placing them with millimeter precision is a problem of physics, management, and sheer human will that is awe-inspiring in its own right. Whether the volume was intentionally designed to mirror a sphere or not, the sheer magnitude of the material forces a shift in perspective. Building on this scale was not merely an act of construction. It was an act of physical philosophy. The pyramid transforms abstract mathematical principles, ratios, angles, constants, into a tangible, mountainous reality. Each of those 2.3 million blocks becomes a single digit in a numerical sentence written across the Giza Plateau. The choice to work on such an immense scale may have been the ultimate statement. It declared that the cosmic order they understood was not a small, delicate thing. It was massive, enduring, and required a monument of corresponding weight to properly represent it. They made mathematics physical, giving weight and shadow to ideas, ensuring their legacy would be impossible to ignore or erase. This leads us from the overwhelming whole to the intricate parts, to the silent, hidden chambers where the most personal layer of this mathematical puzzle may be waiting. The mountain of stone outside is a declaration of cosmic scale, but the true test of the builder's intent lies in the most intimate space they created. Deep within the heart of the pyramid, in the austere solitude of the King's Chamber, rests a single object, a box carved from a single block of red Aswan granite. This is the Coffer, and it presents a mystery of precision that stands in stark contrast to the rough, colossal blocks of the exterior. Its dimensions are not merely impressive, they are unnervingly exact. The interior length is just under 2 meters, the width just under 1 meter, and the depth just under 1 meter. When you calculate its internal volume, you arrive at a figure of approximately 1,166 liters. This number is not random. Researchers have noted its close correspondence to a half of the ancient Egyptian standard liquid measure known as the hecat, multiplied by a factor of 10. This suggests the Coffer may have been designed as a physical standard, a permanent reference for volume set in indestructible stone, but the meaning of its capacity is only half the puzzle. The other half is how it was made. The surfaces inside this granite box are flawlessly flat. The corners are sharp, perfect 90-degree junctions. The walls are of a consistent thickness, and the whole thing was hollowed out from a solid block of one of the hardest stones on Earth. To a modern precision engineer, these tolerances are challenging even with diamond-tipped tools and computer-guided mills. The builders, however, are believed to have had only copper saws, stone drills, and abrasive sand. The conventional explanation involves a tremendous expenditure of labor, using copper blades with quartz sand abrasive to slowly, over years, grind out the interior. Yet the perfection of the result forces a question. Was this merely a triumph of relentless effort, or does it hint at a lost technique, a method of working stone that we have yet to rediscover? The coffer's proportions extend the mystery beyond its construction. The ratio of its external length to its internal length, and the relationship of its volume to its linear dimensions, have been analyzed for hidden ratios. Some researchers propose these internal proportions mirror the same mathematical constants, like pi or phi, found in the pyramid's grand design. If true, this transforms the coffer from a simple container into a microcosm. It becomes a scaled model of the pyramid itself, a perfect geometric solid nestled within the larger perfect geometric solid. Every dimension, inside and out, would then be speaking the same silent mathematical language. This idea of a microcosm is powerful. It suggests the chamber was not just a room, but a sacred space where the universal principles embodied by the entire monument were concentrated, focused into a single, perfect artifact. The coffer, then, is the ultimate key. It is not a key that opens a lock, but a key that unlocks understanding. It demonstrates that the builder's precision was not reserved for the colossal and the distant, but applied with equal rigor to the small, the intimate, and the exact. The mountain outside shouts its mathematics to the horizon, but here, in the silent dark, the coffer whispers the same numbers on a scale you could touch. This convergence of the immense and the miniature points to a unified, holistic vision. But such a vision required more than just brilliant architects. It demanded an army of executors, a society capable of turning abstract geometry into lived reality for generations. How did they manage such a feat, and what was the human story behind the numbers? Within the pyramid's silent heart, the mystery narrows from vast angles to pinpoint shafts of light. From the king's chamber and the queen's chamber, 4 narrow, square-cut channels bore their way through millions of tons of stone to the open air. For centuries, these were dismissed as simple ventilation shafts, a practical solution for deep interior rooms, but their design tells a different story. They are not straight, functional ducts. They are carefully angled, engineered with the same precision as the pyramid's outer faces, and they travel on a deliberate, upward journey with a singular destination, the stars themselves. The true nature of these stellar corridors remained sealed and inaccessible until modern technology allowed us to follow their path. In the 1990s, a German engineer named Rudolf Gantenbrink designed a small, agile robot to navigate the narrow, debris-filled shafts from the Queen's chamber. His work, documented for the world, was a revelation. The robot, named Upuout, crawled upwards for dozens of meters before its camera revealed a startling terminus, a small limestone door with 2 elegant copper handles. This was not a crude, unfinished passage. It was a crafted, sealed feature, a door to nowhere, seemingly symbolic in purpose. Later expeditions would confirm similar doors in the other shafts, and crucially, they mapped the precise angles of these channels. When those angles are projected onto the night sky, as it was around 2500 BCE, each shaft points unerringly to a specific celestial body of profound religious significance. The southern shaft from the king's chamber targets the 3 stars of Orion's belt. In ancient Egyptian mythology, Orion was associated with Osiris, the god of the afterlife, resurrection, and the underworld. The northern shaft from the same chamber points directly to the region of the circumpolar stars, the so-called imperishable ones that never set, symbolizing eternal life. Meanwhile, the southern shaft from the Queen's chamber aligns with Sirius, the brightest star in the night sky. Sirius was linked to Isis, the goddess of magic and the wife of Osiris. Its heliacal rising, its first appearance just before dawn after a period of invisibility, heralded the annual flooding of the Nile and was a pivotal moment of rebirth in the Egyptian calendar. As Egyptologist Mark Lehner has explained, this was not casual stargazing. This was theology made manifest in architecture. The pyramid was designed as a machine for the king's soul. The shafts were not for air but for spirit. They provided a direct conduit, a celestial highway for the pharaoh's essence to travel from his physical resting place to join these specific, divine entities in the heavens. This transforms our understanding of the entire structure. The Great Pyramid is not a static tomb, sealed and forgotten. It is a dynamic instrument, an astronomical clock, and a spiritual launchpad frozen in stone. Its architecture was designed to capture a moment in cosmic time, to align with these stars at a specific epoch, thereby permanently linking the king's legacy to the eternal cycles above. Imagine the intention. During certain rituals or at the moment of the king's passing, priests might have envisioned his soul ascending these narrow, dark channels, drawn like a beacon to the stars of Osiris and Isis, to be reborn among the undying lights of the north. The precision required to achieve these alignments, to angle a narrow shaft through hundreds of feet of solid masonry so that it points true to a star for centuries, is yet another layer of mathematical and observational genius. It means the builders did not just look at the sky, they mapped it onto the earth with breathtaking accuracy, embedding a permanent star chart into the very fabric of the monument. The stellar corridors answer the question of why with poetic force. They reveal a civilization that saw no separation between the earthly and the celestial, between engineering and faith, between a block of limestone and a pathway to eternity. From the dark interior of the pyramid, step out onto the sands of the plateau at dawn. The rising sun casts long shadows, connecting the three great pyramids in a single, sprawling silhouette. This is the moment the hidden code expands. We have been decoding a single monument, but the true masterpiece may be the entire canvas. The Great Pyramid is not an isolated wonder. It is the central piece of a vast, open-air diagram etched into the Giza Plateau, a design where the enigmatic Sphinx is not a lonely guardian, but an essential anchor in a unified geometric plan. To understand this, you must shift your perspective from the ground to the sky and see the site not as a collection of separate tombs, but as a single, intentional composition. Researchers examining the precise positions of the pyramids and the Sphinx have uncovered geometric relationships that are difficult to dismiss as random. The centers of the three main pyramids, for instance, can be connected to form a near-perfect isosceles triangle on the desert floor. More strikingly, the axis running from the center of the Great Pyramid through the center of the second pyramid, when extended, points directly to the Sphinx. This is not a vague alignment. It is a specific, measurable line that suggests the Sphinx location was not chosen for a convenient quarry, but was plotted as a deliberate focal point in a grand scheme. The Sphinx itself, a lion with a human face gazing eternally eastward, adds a temporal layer to this geometry. On the equinoxes, the sun rises directly over its shoulder when viewed from a specific point near the Great Pyramid. This transforms the entire plateau into a colossal solar clock, with the monuments acting as permanent gnomon and markers. The work of researchers like Robert Bovell pushed this celestial connection even further. His Orion correlation theory proposed that the ground layout of the three Giza pyramids is a precise terrestrial map of the three stars of Orion's belt as they appeared in the sky around 10,500 BCE. He argued the relative brightness of the stars is mirrored by the varying sizes of the pyramids, and that the Nile River was intentionally represented by the Milky Way. While the specific dating and some details of this theory remain hotly debated within academia, its core insight is powerful. It encourages us to view Giza holistically, as a ritual landscape designed to mirror the heavens. Whether one accepts the full Orion correlation or not, the geometric and astronomical relationships between the structures are tangible. They suggest the master architects were thinking on a scale far grander than any single building. They were surveying the entire plateau as a sacred space, a place where the geometry of the Earth was meant to resonate with the geometry of the cosmos. The Sphinx, then, is the linchpin. Its form, its orientation, and its relationship to the pyramids complete a circuit. It grounds the celestial blueprint, providing an earthly focal point, a lion, symbol of solar power and guardianship, that stares toward the horizon where these sacred stars would rise. This unified vision transforms Giza from a necropolis into a permanent statement. It was a machine built not just for a king's journey, but to enact and eternalize a profound belief. The desert was their parchment, and the monuments were the indelible ink of a message written in stone and aligned with stars, a message declaring that the order of heaven and the order of earth were one and the same. But the celestial alignments of the pyramids and the Sphinx point to a sky that is not fixed. The stars themselves slowly drift over millennia, tracing a grand cosmic circle. This introduces the most profound and far-reaching concept of all, the precession of the equinoxes. Our planet spins like a top, but its axis wobbles very slowly over a cycle of approximately 26,000 years. This means the north celestial pole shifts, and the constellations marking the equinoxes gradually rotate through the zodiac. It is the great clock of the ages, a cycle so vast it transcends human history. The astonishing proposition made by some researchers is that the builders of Giza not only knew of this cycle, but deliberately encoded its length into the dimensions of the Great Pyramid. One of the most cited correlations involves the pyramid's perimeter. If you take the original base perimeter and multiply it by 43,200, a number that appears in ancient myths worldwide, you get a figure remarkably close to the Earth's equatorial circumference. But look at that multiplier, 43,200. It is not just a random large number. It is precisely 1/6 of 259,200, which is a close approximation of the number of years in a single degree of precessional shift. The mathematics weaves together planetary measurement and cosmic time. Authors like Graham Hancock have explored this connection in depth, suggesting that such precise numerical relationships cannot be dismissed as mere chance. They argue the pyramid was designed as a geodetic and temporal benchmark, a stone repository of knowledge about the Earth's place in a grand celestial rhythm. This idea pushes the boundaries of conventional history to its limit. It asks us to consider if the monument was intended not merely as a tomb for a king, but as a warning or a legacy for an entire epoch, a permanent record set in stone to survive a cataclysm or the slow erosion of cultural memory. Mainstream Egyptology, however, approaches this with extreme caution. Scholars point out that there is no textual evidence in any Egyptian source that mentions a 26,000-year cycle or demonstrates an understanding of axial precession. The numerical correlations, they argue, are fascinating but often rely on selecting specific modern measurements and conversion factors that the ancient architects would not have used. The line between an intentional code and a profound coincidence becomes exceptionally thin here. Yet, the persistence of these numbers is haunting, whether by design or by a synchronicity that speaks to a deeper order in the universe. The pyramid's geometry seems to whisper of cycles far longer than a human life or even a civilization span. It positions the structure as a silent sentinel keeping track of time on a scale we are only now beginning to comprehend. If there is intentionality behind it, the implication is staggering. It suggests the builders possessed a cosmology of almost unimaginable depth, viewing their work not as an endpoint, but as a marker in an endless, turning wheel of celestial time. This transforms the pyramid from a point in history into a needle on the face of a clock whose hour hand moves once every 26,000 years. The stars mark a grand celestial clock, but the same mathematical harmony echoes in the smallest patterns of life on Earth. Look closely at the heart of a sunflower. Its seeds do not grow in random chaos. They spiral out from the center in two opposing directions, and if you count those spirals, you will find a very specific set of numbers. 21 spirals curling one way, 34 the other, or perhaps 34 and 55. These are not just any numbers, they are consecutive terms in a sequence discovered by the medieval Italian mathematician Fibonacci, yet it describes a pattern nature has used for eons. The Fibonacci sequence begins simply 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. Each new number is the sum of the two that came before it. This creates a rhythm of growth found in pine cones, pineapples, and the arrangement of leaves on a stem. But the sequence holds a deeper secret. As you move along the line of numbers, if you take any number and divide it by the one that came before it, the ratio gets closer and closer to a very familiar constant. 5 divided by 3 is 1.666, 13 divided by 8 is 1.625, 34 divided by 21 is 1.619. The further you go, the more precisely the ratio approaches 1.618, the Golden Ratio Phi. This is the profound link. The Fibonacci sequence is nature's algorithm for approximating and expressing phi in physical form. It is the dynamic pathway that growth follows to achieve a state of perfect, harmonious proportion. So the question for our pyramid becomes inevitable. If phi is whispered in its slopes and chambers, could the very pattern of its creation, the blueprint in the architect's mind, have also followed this organic Fibonacci logic? We must search not for the sequence written in stones like numbers on a page, but for its spirit woven into the proportions. Some researchers analyze the pyramid's internal layout, the distances between chambers, the heights of certain courses, looking for segments that relate to each other as consecutive Fibonacci numbers. For instance, if you consider the pyramid's height from the base to a specific architectural feature and compare it to another key measurement, do those lengths stand in a ratio of, say, 8 to 13 or 13 to 21? The analysis is intricate and definitive proof is elusive, as the pyramid's design is a symphony of many interlocking ratios, yet the aesthetic result is undeniable. The Great Pyramid does not feel stark or abrupt. Its form has a serene, inevitable quality to it, a visual rhythm that feels strangely organic for a mountain of stone. This may be the true echo of the Fibonacci principle. The builders, through their deep empirical understanding of geometry and harmony, may have intuitively arrived at proportions that resonate with the same mathematical truths that govern branching trees and unfurling ferns. They were not copying nature, but perhaps tapping into the same universal source code. The pyramid, therefore, stands at a magnificent intersection. It is a product of supreme human intention and will, yet its form speaks the ancient pre-human language of growth and proportion. It bridges the crafted world and the natural world, suggesting that the highest architecture does not impose order upon nature, but respectfully mirrors the order already there. This realization shifts our view once more. If the pyramid's design is woven into the fabric of natural law, then perhaps its purpose was not just to reach for the stars, but to root itself in the very principle of life itself. The mathematical echoes from nature lead us to a modern claim so precise it feels like a deliberate signal. scattered across the internet is a startling assertion. The geographic coordinates of the Great Pyramid encode the speed of light. The numbers are undeniably compelling. The pyramid's latitude is approximately 29.979245 degrees north. The speed of light in a vacuum, measured in meters per second, is 299,792,458. At first glance, the alignment is breathtaking. It suggests the builders not only understood this universal constant, but permanently stamped it onto the Earth at the very location of their greatest achievement. The idea captures the imagination because it promises a direct, numerical bridge between an ancient mind and our most fundamental modern physics. It transforms the pyramid from a historical artifact into a cosmic telegram, a message across millennia saying we knew. But does this correlation hold up to scrutiny? Or does it reveal more about our own desire to find meaning than about the intentions of the past? To understand this, we must dissect the claim with both open-minded curiosity and a critical eye. The first issue is the unit of measurement. The speed of light figure is given in meters per second. The meter, however, is a modern unit, defined in the late 18th century based on a fraction of the distance from the equator to the North Pole. The ancient Egyptians used the royal cubit. There is no historical evidence to suggest they had a concept of the second as a precise unit of time, let alone used it in a geodetic coordinate. The match, therefore, relies on translating the pyramid's position into a measurement system its builders could never have known. The second issue is the placement of the decimal point. The latitude is a coordinate. The speed of light is a velocity. To make them appear similar, we must compare the digits of the latitude after removing the decimal point to the digits of the speed of light. This is an arbitrary numerical manipulation. As physicists like Sean Carroll have pointed out, with the infinite number of constants and measurements in the universe, and the infinite ways to manipulate digits, finding such alignments by chance is statistically almost inevitable. It is a form of numerology, the search for meaningful patterns in numbers without a clear causal link to intent. Historians add another layer of context. The precise measurement of the pyramid's latitude itself is a modern calculation relying on satellite technology. The ancient Egyptians certainly understood latitude in a practical sense. They could track the sun's angle, but pinning a location to a 9-digit decimal degree precision was far beyond their technical capability. So, what are we left with? A fascinating coincidence, a case study in what psychologists call pareidolia, the human tendency to see meaningful patterns, like faces in clouds, in random data. This does not diminish the pyramid's genuine marvels. Instead, it challenges us to ask a deeper question. Why are we so compelled to project our modern scientific framework, our meters and seconds and constants, onto this ancient stone? Perhaps it is because the pyramid's true, demonstrable precision in its own context, its alignment, its proportions, its use of pi and phi with the tools they had, is so advanced that it feels like it should contain all knowledge. The speed of light coincidence becomes a mirror. It reflects our own awe and our own assumption that for something to be truly profound, it must speak directly to our modern understanding of the universe. The pyramid's real code, however, may be written in a different language altogether, a language of stellar alignments, harmonic geometry, and symbolic cosmology that is profound on its own terms without needing validation from 20th century physics. This enigma serves as a crucial lesson in interpretation, reminding us that the most powerful mysteries often resist the easy, viral answer, inviting us instead into a more nuanced and ultimately more rewarding conversation with the past. This brings us to one of the most elegant and enduring interpretations of the pyramid's form, an idea that transforms it from a tomb into a philosophical statement carved in stone. It is known as the squaring of the circle. For millennia, this was the ultimate geometric puzzle, a challenge that captivated thinkers from Plateau to Leonardo da Vinci. The goal was deceptively simple. Using only a compass and a straight edge, construct a square with exactly the same area as a given circle. It is a problem of pure geometry that was finally proven mathematically impossible in the 19th century. Yet, long before that proof, the Great Pyramid seems to offer a breathtaking physical approximation of this very ideal. The relationship lies in those core dimensions we have already explored. If you take the pyramid's height as the radius of a circle, the circumference of that circle is remarkably close to the perimeter of the pyramid's square base. In other words, the builders created a structure where a circle defined by its vertical measure and a square defined by its horizontal measure share the same boundary length. They found a way to make the circle and the square speak the same numerical language. Historian of mathematics John Carlos Baez notes that while the pyramid does not solve the classical problem with perfect mathematical precision, it embodies its spirit with astonishing accuracy. The symbolic weight of this achievement cannot be overstated. In ancient cosmologies across the world, the circle was universally seen as a representation of the heavens, the divine, the eternal and cyclical nature of the cosmos. The square, by contrast, represented the earth, the four cardinal directions, the material and stable realm of human existence. To square the circle was therefore more than a mathematical exercise, it was a metaphysical quest. It was an attempt to harmonize the celestial with the terrestrial, to demonstrate that the laws of the sky could be faithfully mapped onto the order of the earth. This is precisely what the pyramid's geometry achieves. It becomes a three-dimensional theorem, a permanent meditation on unity. The architect, in choosing the specific proportions that interlock pi and the base dimensions, was effectively declaring that the king's monument, and by extension his kingdom, existed at the perfect intersection of cosmic and earthly law. The structure is a declaration that the pharaoh's authority was not merely political but cosmological, sanctioned by the same principles that govern the motion of the stars and the shape of the horizon. So we must see the pyramid not as an attempt to solve a homework problem for future mathematicians, but as a profound architectural ritual. The act of building it was the act of proving this philosophical concept in limestone and granite. Each perfectly placed block was a step in a ceremonial demonstration that the circle of heaven and the square of earth could be brought into a state of magnificent, tangible balance. This transforms our understanding of its purpose yet again. It was likely built not just to house a body, but to perform an idea, to make a foundational truth of their universe permanently visible and unassailable. In this light, the slight mathematical imperfection is almost poetic. It reminds us that this was a human creation, an aspiration toward a perfect ideal, forever captured in its majestic, striving form. The geometry we have seen is a silent score, waiting for the right conditions to be heard. Step inside the king's chamber, and the air feels different, thick with a quiet that seems to hum just below the threshold of sound. This is the realm of archaeoacoustics, a field that asks whether ancient builders designed their sacred spaces not just for the eye, but for the ear. Could the precise dimensions of the pyramid's inner chambers create specific resonant frequencies, turning the entire structure into a colossal stone instrument? The idea moves beyond simple echoes. It suggests the architects understood harmonic ratios, the same mathematical relationships that create the pleasing intervals in music, like the perfect fifth or the octave. Researchers examining the chamber have noted that its dimensions, a double cube of specific proportions, naturally favor certain frequencies. When an acoustic engineer models the space, they find it amplifies sounds in the lower hertz range, frequencies that can be felt in the chest as much as heard with the ears. This is not random. In sacred geometry, these proportions are often linked to cosmic harmony, the belief that the universe itself vibrates with a fundamental frequency. A ritual conducted in such a space with chanting or the strike of a ceremonial instrument would not just be heard, it would be felt physically, washing through the participants and altering their state of awareness. The long, sloping grand gallery adds another layer to this acoustic theory. Its corbelled walls and steep incline act as a sophisticated sound duct, potentially channeling and focusing vibrations from the entrance up toward the inner chambers. Some experiments have shown it can create a standing wave, a phenomenon where sound reflections reinforce each other to create a sustained, resonant tone. Imagine a ceremony where a single note sung at the gallery's base is gathered and amplified as it rises, transforming into a powerful, enveloping resonance by the time it reaches the chamber door. This transforms the pyramid from a silent monument into an active participant in ritual. The work of pioneers like John Stuart Reid, who has conducted extensive acoustic testing in ancient sites, lends credence to this possibility. He proposes that the Egyptians may have used sound as a tool for healing, meditation, or communing with the divine, viewing specific frequencies as a bridge to other states of being. The chambers, then, were not just rooms, they were carefully tuned resonators. The stone itself becomes the medium for an experience that bypasses intellect and speaks directly to the body and spirit. This auditory dimension of the code suggests the pyramid's legacy is not solely visual or mathematical, but deeply sensory. It implies the builders saw harmony as a multi-sensory truth, a principle that could be expressed in the angles of a wall, the ratio of a chamber, and the vibration of the air within it. They may have been composing a symphony in limestone where the architecture itself was the instrument and the ritual was the song. The stone vibrates with a silent harmony, but the numbers themselves were never merely measurements. They were prayers. To truly understand the mathematical code of Giza, we must listen to the ancient Egyptian mind, a mind for whom numbers were alive with spiritual power. Their architecture was a language, and the recurring numbers were its most sacred words. This is the world of symbolic numerology, where geometry meets the divine. Take the number 4, it was far more than a quantity. It represented completeness, stability, and the fundamental order of the cosmos. The 4 cardinal directions defined the world. The 4 sons of Horus guarded the canopic jars. The 4 pillars held up the sky. So when the Great Pyramid rises with 4 triangular faces oriented to the 4 cardinal points with uncanny precision, it is not just an engineering choice. It is a monumental declaration. The structure becomes the stable, squared center of the world, a fixed point anchoring the chaos of the universe into perfect, eternal mat. The number 7 held similar profound weight. It symbolized perfection and cyclical completion. There are 7 steps in the Egyptian creation myth. The solar cycle was deeply significant. Some researchers examining the construction note the potential for a 7-stage building process, from site alignment to the final casing stones. While debated, the symbolic intent is clear. The pyramid's ascent could mirror a spiritual ascent, a stairway of 7 tiers toward the imperishable stars. This intertwining of number and belief is powerfully documented in the pyramid texts, the oldest known religious writings in the world, inscribed inside 5th and 6th dynasty pyramids. These spells for the pharaoh's journey to the afterlife are saturated with numerical symbolism. They speak of the king uniting with the sun god Ra, of crossing the celestial waters, of becoming one with the eternal lights. The architecture gives physical form to these prayers. The pyramid's shape is a frozen ray of sunlight, its apex a point of union between earth and heaven. As Egyptologist James P. Allen explains, the texts reveal a world view where mathematics, astronomy, and theology were inseparable strands of the same cosmic truth. The pyramid was the machine built to operate that truth. Consider the 5 parts of the human soul in Egyptian belief: the Ka, or life force, the Ba, or personality, the Ak, the transformed spirit, the Ren or name, and the Shoot, the shadow. While not directly mapped like a schematic, the pyramid's design can be seen as a vessel for all these elements. The hidden burial chamber protects the physical form, the ascending corridors guide the bar, the shining apex aims for the Ak's stellar transformation, and the immortal stone itself ensures the Ren and Shoot endure forever. This is where the hidden code reveals its deepest layer. The Pi ratio and the Phi proportion were not abstract discoveries for the architects. They were glimpses of the divine syntax, the mathematical grammar with which the gods built reality. To replicate those ratios in the pharaoh's house of eternity was to align his destiny with the very fabric of creation. Therefore, the search for a purely secular, modern mathematical message in the pyramid may miss the point entirely. For its builders, there was no separation. The precision was an act of devotion. The alignment was an act of worship. Every perfectly placed block was a syllable in a continuous stone hymn sung to the cosmos. The pyramid stands as the ultimate testament to a civilization that did not see science and spirit as opposing forces, but as a single, glorious pursuit of eternal harmony. But what if the harmony we hear is an echo, not a composed melody? This is the quiet, compelling voice of practicality that asks us to step down from cosmic wonder and onto the hot, dusty construction site. Could the pyramid's astonishing mathematical relationships be not a hidden code, but a simple byproduct of getting the job done? Imagine the scene not of master geometers, but of foremen shouting orders across a sprawling, noisy worksite. Their primary concern was not encoding pi for the future, but ensuring the next course of stone sat perfectly level and at the correct angle. For this, they relied on a brilliantly simple tool, the seek. This was their building manual, a unit of slope defined as so many palms and fingers of horizontal run for a single cubit of vertical rise. For the Great Pyramid, the chosen seeked was 5 palms and 2 fingers. It was a clean, memorable, and most importantly, repeatable number. A worker could check the angle of any section by holding a marked rod against a taut guide rope. This practical system guaranteed consistency across decades of labor and millions of blocks. And here is the crucial point. When you translate that practical, buildable seeked into the abstract language of modern trigonometry, the slope it produces is 51.84 degrees. From that single, workmanlike decision, a cascade of mathematical relationships emerges automatically. The ratio of the pyramid's perimeter to its height naturally approximates 2 pi. The geometry of the faces inherently flirts with the golden ratio. As archaeologist Mark Lehner, who has led excavations at Giza for decades, emphasizes, these builders were masters of applied, not theoretical, mathematics. Their genius was in devising a simple, fault-tolerant method that could be executed by thousands. The sublime ratios we marvel at could very well be the unconscious offspring of a supremely elegant construction technique. This perspective wields Occam's razor, the principle that the simplest explanation is often the best. It asks, is it more likely that a Bronze Age civilization embedded a multidimensional mathematical puzzle using constants they left no other record of, or that they were brilliant engineers who found the most stable, buildable angle and stuck to it? The sheer accumulation of coincidences, however, gives even the most practical mind pause. Could simple, consistent methods really produce such a dense web of correlations to celestial cycles, planetary dimensions, and natural growth patterns entirely by accident? The mystery endures not because one side has all the answers, but because both narratives are powerfully plausible. The pyramid stands as a Rorschach test in stone. We can look at it and see the triumph of a superbly organized labor force, solving immense logistical problems with simple, brilliant tools. Or we can look at it and see a vessel of transcendent knowledge, a deliberate attempt to crystallize cosmic truth. Perhaps the most profound insight is that these views are not mutually exclusive. The ancient Egyptian mind likely saw no wall between the practical and the profound. Building with perfect, repeatable precision was itself an act of sacred alignment. The Sikh was not just a building code, it was a divine recipe. In choosing that specific, stable slope, they were also, whether they calculated it in our terms or not, choosing to build in harmony with a deeper order they perceived in the world. The code, then, may be in the eye of the beholder, but the intention to build something perfect, something that mirrored the stability of the cosmos, was undoubtedly in the heart of the builder. The desert today is a sea of wind and sand, but the stones themselves remember a different climate entirely. Look closely at the limestone walls of the Sphinx enclosure, at those deep, undulating vertical channels carved into its sides. To a geologist's eye, these are not the marks of a dry, sandy wind. They are the unmistakable signature of water, and not a little of it. These patterns speak of torrential, sustained rainfall over a very, very long time. This observation forms the core of the water erosion hypothesis, a geological argument that sends tremors through the traditional timeline of Giza. The mainstream attribution places the Sphinx and its neighboring pyramids in the 4th dynasty, around 2500 BCE. But the geology of the region tells us that the last period of significant, prolonged rainfall in this part of Egypt ended much earlier, perhaps as far back as 5000 BCE or even before. If the heavy erosion on the Sphinx enclosure was caused primarily by rainwater, then the structure must have been standing there, exposed to the elements, for thousands of years before the pharaoh Coffer is said to have built it. This is the controversial case put forward by geologist Robert Schoch of Boston University. After examining the erosion patterns firsthand, Schoch concluded that the Sphinx shows evidence of precipitation weathering that could only have occurred during a much wetter climatic epoch. His analysis suggests a construction date not of 4,500 years ago, but potentially 7,000, 8,000, or even older. The implications are staggering. If the Sphinx is that ancient, then the entire Giza complex and the mathematical code within the Great Pyramid may belong to a different chapter of human history entirely. It forces a radical question. Who were the builders if not the 4th dynasty Egyptians we know from the history books? Mainstream Egyptology offers a different geological interpretation. Experts like Mark Lehner and geologist James Harrell argue that the erosion could be the result of other processes, such as wind and sand abrasion, or perhaps chemical weathering from moisture in the air and rising groundwater. They point out that the distribution of the erosion is not uniform and could be linked to the varying quality of the limestone bedrock itself. The debate is highly technical, centered on the interpretation of weathering profiles and climatic data. Yet, the sheer force of the water erosion hypothesis cannot be easily dismissed. It invites us to consider a narrative of forgotten epochs. Could an advanced predynastic civilization have existed, one that possessed the sophisticated astronomical and geometrical knowledge encoded at Giza, only to vanish into the mists of time, leaving their legacy to be adopted and perhaps only partially understood by the pharaohs who came later? This transforms the hidden mathematical code from a static artifact of a known culture into a dynamic message from a lost one. The numbers in the stone become a legacy, a set of instructions or a record passed down from a people whose name we do not know. The precision of the pyramid's alignment and proportions suddenly feels less like an achievement of an emerging kingdom and more like the refined product of a mature, perhaps global, scientific tradition. Whether one sides with the geologists or the Egyptologists, the hypothesis performs a vital service. It shakes the foundations of historical certainty and opens a door to profound possibilities. It asks us to look at the weathered face of the Sphinx not as a contemporary of the pyramids, but potentially as their ancient, silent predecessor, guarding secrets far older than we ever dared to suppose. The weathered stones of Giza have always invited interpretation, but the formal quest to decipher them as a mathematical text began in earnest in the 19th century. This pursuit, known as Pyramidology, is a story as layered as the monument itself, a chronicle of brilliant obsession, spiritual yearning, and the human desire to find order in the ancient past. It starts with a London publisher named John Taylor. In the 1850s, Taylor, who had never visited Egypt, became fixated on the pyramid's measurements. Working from survey data, he was the first to propose that its proportions encoded the mathematical constant pi, and that its dimensions were based on a sacred unit of measure derived from the Earth's rotation. For Taylor, this was not merely geometry. It was divine revelation, proof of a God-given plan. His work, though dismissed by the scientific establishment of his day, provided the foundational ideas for the field and caught the imagination of a far more influential figure. That figure was Charles Piozzi Smyth, the Astronomer Royal for Scotland. A respected scientist, Smyth traveled to Giza in 1865, armed with the latest surveying equipment, determined to take the most precise measurements ever recorded. His meticulous work yielded data of genuine value, but his interpretation veered into prophetic territory. Smyth became convinced the pyramid's internal passages were a stone timeline of human history, with each inch representing a year. He correlated these measurements with biblical events, from the Exodus to the birth of Christ, and even projected future dates for the Second Coming and the end of the world. His best-selling book, Our Inheritance in the Great Pyramid, fused exacting science with evangelical prophecy, creating a potent and popular narrative. For the Victorian public, this was electrifying. It presented the ancient world not as a primitive place, but as a repository of lost wisdom and divine truth measured to the inch. Smyth's legacy is profoundly dual. As historian of science John David North notes, he exemplified a period where the boundaries between rigorous measurement and religious mysticism were frequently porous. Smyth the astronomer collected invaluable data. Smyth the pyramidologist used that data to build an elaborate theological edifice that mainstream science could not support. The 20th century saw pyramidology fragment and evolve. Some followers continued Smyth's millenarian calculations, updating the prophetic timeline with each New World event. Others stripped away the religious framework and focused purely on the geometric and astronomical correlations, searching for a lost science instead of a lost religion. Figures like the journalist and historian Peter Tompkins brought these ideas to a mass audience in the 1970s, presenting the pyramid as evidence of a sophisticated, perhaps even Atlantean, precursor civilization. This shift reflected the changing spiritual landscape, swapping Christian prophecy for notions of ancient astronauts and forgotten high cultures. Throughout all these iterations, the pattern identified by scholars remains constant. Pyramidology acts as a mirror for the anxieties and aspirations of the era interpreting it. In the industrially confident yet spiritually uncertain Victorian age, it offered a measurable proof of God's plan. In the more secular but technologically awestruck 20th century, it offered evidence of a lost scientific golden age. Understanding this history is our most crucial tool. It allows us to approach the pyramid's genuine enigmas, its staggering precision, its celestial alignments, its elegant proportions, with both wonder and discernment. The legacy of pyramidology teaches us to separate the measurable fact of the pyramid's architecture from the often grand and unverifiable claims built upon it. We can admire the undeniable sophistication of its pi ratio without needing it to be a prophecy. We can stand in awe of its stellar alignment without requiring it to pinpoint a date for the apocalypse. The stones themselves are silent. They do not tell stories of biblical timelines or sunken continents. They speak the quieter, more profound language of mathematics and astronomy. By appreciating the long and tangled history of those who tried to make them speak in other tongues, we clear the air. We prepare ourselves to listen to what the architecture actually says, to hear the true whisper of the past through the noise of centuries of interpretation. This careful listening brings us to the most critical perspective of all, the view from within mainstream scholarship, which asks the simplest and most challenging question of all. The stones of Giza are not speaking in isolation. To hear their full message, we must listen to a chorus of mountains. From the jungles of Central America to the plains of China, pyramidal forms rise from the earth, built by cultures separated by vast oceans and millennia. This global echo forces a monumental question onto the stage. Were these similar shapes born from a shared, forgotten source of knowledge, or do they represent the independent flowering of the human mind reaching for the same celestial truths? The answer lies not in the shape itself, but in the mathematical whispers we have learned to hear within it. Consider the Avenue of the Dead at Teotihuacan, the ancient metropolis in what is now Mexico. At its heart stands the Pyramid of the Sun. When archaeologists measured its base perimeter and compared it to its height, they found a ratio startlingly close to pi. Just as at Giza, the builders seemed to encode the circle within a square monument. This is not a vague similarity. It is a precise geometric choice made by a culture with no known contact with Egypt. Meanwhile, the Maya masters of time constructed their step pyramids as precise astronomical instruments. The Pyramid of Kukulkan at Chichen Itza is a legendary example. At the spring and autumn equinoxes, the play of sunlight and shadow creates the illusion of a serpent slithering down the northern staircase, connecting the structure to the solar cycle in a dramatic public display of celestial alignment. This is a different expression of the same principle witnessed at Giza, architecture as a permanent, interactive calendar, binding human ritual to cosmic motion. In China, ancient earthen pyramids, like the enigmatic tomb of Emperor Qin Shi Huang, often align with cardinal directions and incorporate cosmological symbolism, though their full geometric secrets remain less explored. Archaeologists like Saburo Sugiyama, who has spent decades excavating Teotihuacan, caution against rushing to connect dots. He emphasizes that each culture expressed its cosmology through its own unique architectural language. The Mesoamerican pyramids were often temples for living rituals, not sealed tombs, and their mathematical codes served a different, though equally profound, spiritual purpose. The similarities, therefore, may not point to a single teacher, but to a universal student, humanity itself. It appears that whenever a civilization reached a certain peak of organization and looked to the heavens, it discovered the same fundamental relationships. The circle and the square, the solar and stellar cycles, the desire to measure and mirror the cosmos in stone, these are not ideas that need to be transmitted. They are discoveries waiting to be made by any culture with the patience to observe and the genius to build. This global perspective is liberating. It frees the Great Pyramid from the burden of being utterly unique and places it within a wider tapestry of ancient genius. Whether by independent discovery or some faint, lost thread of dissemination, the result is a testament to a shared human impulse. Our ancestors, in their separate corners of the world, all sought to write their understanding of universal order into the most permanent medium they knew, the Earth itself. They were all attempting to square their own circle, to anchor their world to the turning sky, proving that the language of mathematics and astronomy is a native tongue of our species. The silent chambers and measured corridors we know may be only part of the story. For all our centuries of study, the pyramid's full architectural plan remains locked within millions of tons of stone, a final defense against prying eyes. That is, until now. The 21st century has brought a new kind of explorer to Giza, armed not with chisels and dynamite, but with particles from deep space and beams of laser light. This is the quiet revolution of non-invasive archaeology, where the goal is not to break in, but to see through. At the forefront is the International Scan Pyramids Project, a coalition of scientists and engineers from France, Japan, and Egypt. Their mission is audaciously simple: to map the interior of the Great Pyramid without moving a single stone. They achieve this with two extraordinary tools: Muon tomography and infrared thermography. Muons are cosmic particles born in the upper atmosphere from collisions with cosmic rays. They shower down upon us constantly, passing harmlessly through solid matter. By placing ultra-sensitive muon detectors inside and around the pyramid, scientists can track how many of these particles pass through the stone from different angles. Dense, thick rock absorbs more muons, while open spaces or voids allow more to pass through. Over months of data collection, a ghostly image emerges, a negative silhouette of the pyramid's internal density. What these detectors have revealed is nothing short of breathtaking. In 2017, the team announced the discovery of a colossal void, now called the Big Void, located directly above the Grand Gallery. This space is enormous, estimated to be at least 30 meters long, with a cross-section similar to the Grand Gallery itself. It is not a small crack or a builder's pocket. It is a deliberate architectural feature, a hidden chamber on a grand scale that has eluded detection for 45 centuries. Shortly after, a second, smaller void was detected behind the chevrons on the pyramid's north face, a corridor-like structure leading inward. The lead scientist for the Muon imaging, Kunihiro Morishima of Nagoya University, describes the process with a sense of awe. We are not interpreting hieroglyphs, we are reading the pyramid's own diary, written in the language of cosmic rays. The data is clear, he notes. These are not anomalies, they are designed spaces, but what are they? The Scan Pyramids team is deliberately cautious. They are mappers, not interpreters. Yet, the implications ripple outwards. These voids could be structural, designed to relieve the immense weight over the king's chamber, a brilliant feat of ancient engineering foresight. Or they could be ritual spaces, sealed chambers meant never to be entered, containing artifacts or symbolic arrangements that complete the pyramid's spiritual function. Each possibility rewrites our understanding. If they are structural, they reveal a level of architectural calculus far beyond what we credited to the ancients. If they are chambers, then the mathematical code we have been deciphering has entire, silent chapters we have never read. The very existence of the Big Void proves one thing definitively: the full blueprint of the Great Pyramid is still unknown. We have been studying a masterpiece with entire sections of the canvas hidden from view. This modern chapter of exploration humbles our assumptions. For generations, we believed we had essentially mapped the interior. Now we know we have only sketched the outline. The pyramid continues to guard its core secrets, not with curses, but with sheer, overwhelming mass. It challenges our technology, asking us to build better detectors, to collect more data, to think in ways that bridge particle physics and archaeology. The muons streaming from the cosmos are acting as celestial keys, forged in the heart of distant stars, now employed to unlock a mystery under the Egyptian sun. This partnership between cutting-edge science and ancient stone tells us the story is not over. The hidden code may have physical dimensions waiting to be measured, ratios yet to be calculated, and a final, elegant purpose waiting to be understood, all resting in the dark, just beyond our reach, patiently waiting for our ingenuity to finally catch up. A hidden chamber changes what we know about the structure, but a hidden code rewrites what we believe about the mind that built it. We have journeyed through a labyrinth of numbers, angles, and alignments, from the pi in its perimeter to the stars in its shaft. Now we must confront the ultimate question these stones pose, not to our calculators, but to our understanding of history itself. If this mathematical language is a deliberate creation, What does its existence tell us about the timeline of human discovery? The implications are not merely academic, they are paradigm-shattering. They force us to consider two radical yet compelling possibilities about our past. The first possibility is that we are looking at the legacy of a lost scientific epoch. The precision evident at Giza did not emerge from a vacuum. It speaks of a mature, systematized body of knowledge encompassing geodesy, astronomy, and advanced geometry. This knowledge appears fully formed in the archaeological record, with no clear traces of a gradual, stumbling development in the preceding centuries. Where are the crude, experimental pyramids that should logically come before such a masterpiece? Their absence is deafening. Some historians of science, like Stephen Tallman, have explored how complex knowledge can be lost, preserved only in cryptic monuments or fragmented oral traditions after a civilization's decline. The pyramid, in this view, becomes a time capsule, a desperate attempt to preserve a high science in an indestructible medium against an impending dark age. Its code is not a message for us, but a backup drive for a future generation they hoped would be wise enough to read it. The second possibility is perhaps even more profound. It suggests the builders operated from a different intellectual framework entirely, one where intuition and empirical observation fused into a profound grasp of cosmic harmony. They may not have derived pi through abstract calculus, but discovered it through the endless repetition of rope and rod, through a deep, tactile familiarity with circles and squares that revealed their hidden relationship. Their genius was not in inventing the mathematics, but in recognizing it as the sacred grammar of the visible world. The philosopher of science, Paul Feyerabend, argued that many paths lead to knowledge, not just the rigid, analytical model of modern science. The pyramid could be the ultimate artifact of this alternative path, a monument built not from equations on papyrus, but from a visceral, philosophical conviction that the universe is ordered, measurable, and beautiful. This moves the discussion from a technical how to a philosophical why. Why encode this knowledge in stone? The answer may be that for them, knowledge was not merely information to be used, it was a sacred trust to be embodied. To build a perfect shape was to participate in the maintenance of cosmic order, or mat. The pyramid was their most powerful act of worship, a permanent prayer in geometry that stabilized the world. So, is the Great Pyramid an anomaly, a stunning accident on the slow march of progress? Or is it a beacon, evidence of a peak of understanding from which we later declined, only to spend millennia laboriously rediscovering what was once known? This is not about finding aliens or Atlantis, but about humility. It asks us to consider that the narrative of human knowledge as a straight, upward line from primitive to advanced may be a comforting fiction. History might be a spiral or even a series of waves where insights are gained, lost in cataclysm or cultural collapse, and then painfully regained. The silent, waiting stones of Giza do not give easy answers. They simply present the evidence of their own perfection, a permanent question mark etched against the desert sky, challenging us to reconsider where we came from and what we have forgotten. The sheer volume of mathematical whispers within the stone is now impossible to ignore. We have before us a scattered constellation of evidence, each point a bright, compelling star. The pi proportion in the slope, the potential phi in the faces, the stellar alignments of the shafts, the geodetic suggestions of the cubit. The human mind, faced with such a collection, instinctively yearns to connect the dots, to draw the lines that reveal a hidden picture. But here, at the climax of our investigation, we must pause and perform the most difficult act of all. We must become both advocate and skeptic, weighing the possibility of a grand, unified design against the powerful allure of coincidence. On one side of the scale, we place the argument for intentionality. Its greatest strength is not any single number, but their cumulative weight and their interlocking nature. the pi relationship is not a standalone fact. It emerges directly from the chosen seat, the practical building angle. That same angle then generates proportions that flirt with the golden ratio. These are not separate, unrelated codes. They are different melodies arising from the same fundamental chord struck by the architects. Furthermore, these geometric choices are married to astronomical ones. The same precision used to square the base was deployed to align the monument to true north and to target specific stars with narrow shafts. This convergence of mathematical and celestial purpose is difficult to dismiss. As archaeoastronomer Giulio Magli has often stated, the alignments are measurable, repeatable facts of the architecture. They require deliberate, sustained observation and execution. In this light, the pyramid begins to look less like a collection of happy accidents and more like a symphony composed in multiple movements, geometric, astronomical, and geodetic, all following the same score of cosmic harmony. Yet the other side of the scale holds a profound and necessary caution. The human brain is a pattern recognition engine, and it is famously prone to a phenomenon called apophenia, the tendency to perceive meaningful connections in random or meaningless data. We see faces in clouds and hear hidden messages in recorded music played backward. When we approach an object as rich and numerically complex as the Great Pyramid, armed with our modern knowledge of universal constants, the risk of apophenia is immense. We may be connecting dots the builders never drew. Statisticians remind us that with enough data points and enough ways to manipulate measurements, converting cubits to meters, comparing perimeters to circumferences, playing with decimal placements, sooner or later, you will find a match to any significant number you seek, from the speed of light to the fine structure constant. The tenuous links, like the latitude coincidence, often crumble under this scrutiny, as they rely on units and concepts foreign to the builder's world. So where does the balance settle? Most serious researchers today occupy a nuanced middle ground. They acknowledge that certain core features, the cardinal alignment, the pi proportion from the seat, the stellar targeting of the shafts, are too precise, too functionally integrated into the architecture to be accidental. These are the pillars of the intentional design argument. The more speculative correlations, particularly those involving the Earth's dimensions or precessional cycles, are viewed with healthy skepticism, seen as intriguing but unproven possibilities that may tell us more about our own desire for meaning than about ancient intent. Engineer and historian Christopher Dunn, who approaches the pyramid from a practical manufacturing perspective, argues that the precision we can physically verify in the stonework itself is the only reliable evidence. That precision alone, he notes, is a code worth deciphering, as it reveals a technological capability we are still struggling to explain. This critical synthesis is not a defeat, it is an empowerment. It hands you the tools to navigate this mystery. You can appreciate the undeniable genius of the celestial alignments without needing to believe the pyramid predicts the future. You can marvel at the mathematical elegance of its form without accepting every numerological claim made about it. The Great Pyramid, in the end, does not need to be a repository of all modern scientific knowledge to be utterly revolutionary. Its true code may be more profound than any single constant. It is the code of a mindset, a testament to a civilization that viewed the universe as an ordered, measurable, and beautiful system, and then poured its collective will into building a permanent physical proof of that belief. They may not have known the number for the speed of light, but they knew with certainty that the stars above and the stones below could be brought into a conversation, and they built a mountain to serve as the translator. The final question, then, shifts from what the numbers mean to why this act of translation felt so essential to the human story. The desert stars still wheel above, as they have for all the centuries since the last casing stone was set in place. Our journey through the corridors of this mystery, from the pi in its slope to the stars in its shafts, leaves us not with a single definitive answer, but with something perhaps more valuable, a profound and enduring question. The evidence laid before us is a mosaic, each piece the uncanny alignments, the elegant proportions, the sheer, silent precision compelling in its own right. Together, they form a picture that refuses to be simple. You may look upon this ancient mountain and see the ultimate triumph of practical engineering, a society so brilliantly organized that sublime mathematics emerged naturally from their flawless execution. Or you may gaze at its weathered face and perceive a deliberate vessel, a time capsule of knowledge from a science we have since forgotten, or from a wisdom that understood the cosmos as a harmonic whole. Both interpretations are testaments to human genius. Both are valid ways of listening to the story the stones tell. What remains undeniable and truly magnificent is the pyramid's timeless power to pull our gaze upward and inward. It stands as a permanent challenge not to our technology, but to our imagination and our understanding of history's possibilities. For over 4,000 years, it has silently compelled every generation that encountered it to measure, to calculate, to wonder, and to dream. In this way, the most profound hidden code within the Great Pyramid may have nothing to do with pi or precession. Its deepest function might be as an eternal catalyst. It is a machine built not for moving stone, but for moving minds. It forces us to look at the night sky with a surveyor's eye, to measure our world with a philosopher's curiosity, and to connect, across the vast gulf of millennia, with the intellects who dared to build a mountain according to a cosmic blueprint. So let this exploration be a beginning for you, not an end. The conversation about these stones is as alive today as it was in the age of the pharaohs, now fueled by muon detectors and cosmic rays. Where does the evidence lead you? Do the whispers of mathematics and astronomy convince you of a grand, intentional design, or do they speak of a more practical, yet no less astonishing, ancient brilliance? The desert holds its silence, but your perspective is the next chapter in this endless story. Share your conclusions, your own theories and questions in the comments below. If you crave more journeys into history's deepest enigmas, subscribe to continue unraveling the mysteries written in stone and star. Keep questioning, keep measuring, and keep looking up. The greatest discoveries often begin with a single, ancient question, patiently waiting in the sand.